Hey friends, welcome back to Civil Engineering Mastery. In this video, we are going to discuss how we can model and analyze the G+5 story commercial building in Staad Pro Connect software. I hope you all are excited to do this project. Without further delay, let's begin now. To start with, let me explain you about the project details. Here we have the drawings for the commercial building. It is having 6 blocks and I have taken only one block in that. So let's do this project in Staad Pro software. We have the framing layout of this. This is a school building. So first let's do the framing in the Staad Pro software. Open the Staad Pro software and here I'm going to do the framing with this structural wizard option. So in this model type you have to select the frame model and just click on the bay frame. If you go to your architectural drawing, so we have the length as 35.65 and here we have 19.4, and if you look into the height it is 2 plus 3.5 into 6, so it is 23 meter. Let's click on the bay frame. So length is 35.65 and then height is 23 meter and width is 19.4. So we have number of bays along length is 1, 2, 3, 4, 5, 6 bays, and number of bays along width 1, 2, 3, and number of bays along height is 1, 2, 3, 4, 5, 6, 7. So this one Staad is equally divided the length. We can change it according to the size what we have. If you look into this, it is having 5.925 in all the bays and last one is having 5.725. We can modify it. Okay. So there is some mistake in this, I think. So this one is not 35.65. So this is 35.55. Now we can add. See, it is equally divided into 5.925. Okay. I think there is some mistake in the dimensions. That's okay, no problem. So there is some mistake in the dimension. So I have corrected it. It is 35.5 and equally divided into 5.925. If you just click on this, see, it is equally divided into 5.925. Give OK. And then let's divide the width side. So the first one is 7.6 and second one is 3.6 and third one is again it is 7.6. Okay. This is 18.8. Now it is okay. And next one is 23 is this one. So this is first one is 2 meter and then 3.5 and then close. It will ask you, would you like to merge this prototype into Staad Pro? Give S and then OK. So now you have got the structure. As I have told you, you can check the distance over here. See, it is 2 meter, 3.5 and up to top you have 3.5. See, now we have the model. We can change this one according to the framing plan. Now we have the whole structure. In this we need to do some modifications. Go to this view, just select the ground floor plan and give selected objects. Go to this isometric view. Let's change this one and then we can replicate it to the other floors. If you look into the framing, so in the first bay there is no change because all are similar only. See, this beam is not needed. We can delete this and then these are similar, and when you come here in this area, this bay is same and here we have to do some changes. So let's delete this. This column is also we don't want. You can delete these nodes. You can add the beam over here. Now we can do the modifications. So from this column there is a column here. So at 4.062 meter. So this also we can select. These two we can give Control C, Control V. In the X direction it is 4.062 meter. Give OK. So we have got at this distance, and then again we have the column in 4.825. 4.825 meter. Give OK. So this is done. Next we have to provide the column in the distance of 2.060. So I'm going to select these two columns, Control C, Control V. In the Z direction it is 2.06. We have got the column over here, and again let's take the distance, that is 3.14. So these 8 columns we have got now. Next one is we need this column over here at the distance of 950. So these 3 columns we need. Control C, Control V. In the X direction minus 0.95, give OK. We have got that, and then only this column we need here at a distance of 2.963 minus 2.963. It is not matching with that line, so what we can do is we can just take this column and then at a distance of 5.2 meters, or let's measure here and then paste it. This distance is 2.4 meter, so let's copy this, and then the Z direction it is 2.4 meter in the negative. We have got all the columns over here. Now let's add the beam. Go to geometry, select beams, add beam. So in this, let's connect these two here. So now we have got the similar structure. Next we need to add this beam, and here in the middle we have to add one beam. So go to geometry, beam, midpoint we have added one beam, and then go to beam, perpendicular intersection. So we have added the beams over there, and then this one we can select, give Control C, Control V at a distance of 1.775 we can take, give OK. So this also we have added. Now we have done the proper framing which we have. Rest all we can check. There is no much change in the other areas. So now what we can do is go to view, this view, display whole structure, and go to this view. So here we can delete all these things. So now what we can do is just select this one, then we can delete these things. So now we have only this floor. What we can do is, now let's select only this and then go to geometry, click on this translational repeat in the Y direction, give 2 meter, give OK. Sorry, it was supposed to be negative Y direction. So let me delete this. We have to select this and then give translational repeat in the Y direction, negative 3.5, give OK. So that you will be having here. And next what we can do is again select over here, give translation repeat in the Y direction, negative 2 meter, give OK. Now go to view, isometric view. So you can just go to geometry, add beam. You can just connect all the columns. You can delete this. Now just go to this one. Reference point you can take, and then just you can place the columns like this. At a height of 2 meter, we are going to place the columns. So now we are done with the modeling part. Next we can assign the properties, and then we can do the replication. So it will be easy because since it is a typical floors, we have to assign the member properties and then we can easily replicate to the other floors. We are done with this geometry. Next let's go to properties, define rectangle. So the column sizes we have, we need to apply it in meter. 0.75 is the depth and 0.3 is the width. And we have one more column that is with the 600 mm depth. So let's take 0.6, give add. And then beam also we have 0.75 and 0.3 and 0.6 and 0.3. So first two properties are for column and the second two properties are for beams. Let's go to select. Under beams you will be having parallel to Y. That means your all columns will be selected. So before assigning the property, you have to select the property and then go to the select beams parallel to Y. So under beams, you will be having parallel to option, select Y. First let's select all the columns and then apply this property, give assign, so that this will be assigned. Let's see what are all the columns having 600 dimensions. So only this column we have 600 dimension. Okay, that's fine. Let's delete this property because we don't want only that column to be 600. So let's make all the columns by 300 by 750 only. Next, let's assign the beam property. So what we have to do is we need to select all the main beams. So this is the direction beams parallel to X and beams parallel to Y. So in this, if you see, this is the beams. So in this direction, this beam and this beam, we have the beam depth as 750. So we can select these beams, all these beams are 750, and then this cross beams we can make it as 600 depth. So let's go to Staad beams parallel to Z. I think this we can take it out because this we don't want in the beams to be as 750 depth. So let's make this one and then give assign. Next, let's go to this one, beams parallel to X. So in this only we can select these two beams. So before assigning the property, you have to select the property and then you have to choose beam parallel to X and then you can choose these two, give assign. So now all the properties has been assigned. You can go to here, check missing property. See, no entity with missing property is found. That means all the members have been assigned with the property. Next, we can go to the material definition. Go to material and then select concrete, give assign. If you click on this and go to edit, you can see the properties. Material properties is also assigned, and then this one we can change to 30. Compressive strength we can consider as 30,000. Give OK and then close. Now we have assigned with the member properties. Next, let's go to this geometry. If you wanted to look into the 3D view, you can just go to view and then 3D rendering. So the next part is you have to orient the column because all the columns are oriented in the horizontal direction. So that we need to change. So go to geometry, beams parallel to Y. Go to view, selected objects. So we have all the columns over here which we can orient according to the framing. See, all these columns are oriented in the vertical direction only. So only we have this one column is oriented in the horizontal direction. So let's select all the columns. So if you want to have the quick access toolbar, you can customize quick access toolbar over here. Just click on this, go to more command and then see here to change the angle we have the option called beta angle. You can just click on this and then give OK. See, on the top you have this option called beta angle. You click on this beta angle option and to view give 90 degree. So all the thing will change to 90 degree. So the columns have been assigned. So only this column is oriented in the horizontal direction. Let's select this one and go to beta angle. This one we can make it as 0 degree. Now we have oriented the column the vertical direction. Let's look into the 3D rendering view. See, now all the columns and beams are arranged properly. Just close this window. We are done with the member properties. Next, let's go to this materials, select concrete, go to edit. Let's change this one to M30, give OK and assign. So the concrete property is also assigned. Next, let's assign the support. Go to create, add fixed support, go to view, select all these nodes and then select the support first and then select all the nodes, give assign. We have assigned the support now. Display whole structure. So we are done with this one. Next we need to move on, add the loading part. Let's click on this load and then add load case details. In Staad Pro always you have to define the seismic load definitions first. Before adding any load case details, you have to define the seismic definitions. So in this project, we are going to analyze for the response spectrum cases. So we need to add the seismic definitions. So here we have to select Indian IS 1893 Part 1 2016. So this project is located in Mumbai. Mumbai is coming under Zone 3. So let's select the Zone 3 factor as 0.16. So here we have to enter the value as 0.16, and response reduction factor we need to consider as per the table. Importance factor also we need to consider. If you click on this generate, it will show you this option. So here you can select the city as Mumbai. You go to the code. In table 9, response reduction factor is given. So this comes under moment frame system, RC building with ordinary moment resisting frame. So for this we have to look into the RC notes 1. RC and steel structures in seismic zone 3, 4 and 5 shall be designed to ductile, hence this system is not allowed in this seismic zone. So we cannot use this one, RC building with ordinary moment resisting frame. Since the structure is located in zone 3, we have to go with the RC building with special moment resisting frame. So let's consider the response reduction factor as 5, and then importance factor is for commercial building. So here it is mentioned as it is schools. For one importance factor, let's take 1.5. It is 1.5. Rock type is medium soil, and then RC damping ratio we can consider this. Foundation depth we can give 2 meter. Generate, give add, and then close. So seismic definition is added. When we do the seismic analysis, we need to add the seismic load cases first. Then we need to go with the dead load and live load cases. So first I'm going to add EQ positive X, give add, and then EQ negative X, EQ positive Z, EQ negative Z. In this analysis, we are not going to consider the vertical earthquake forces since the structure is not a complex structure. So we are going to consider only X and Z directions. Next, let's add the dead load cases. Go to loading type, add dead load, give add, and then live load, add, and then close. So under dead load, what are all the loads we need to consider? We have to add the self weight of the slab and then floor finish load. After that, if there is any sunken areas in the toilet, so that we need to consider. Staircase load we need to consider, and then wall loads we need to consider. So let's look into the loading calculations. So I have the loading calculation here. So dead load, first we need to consider the self weight of the slab. Let's consider 200 mm thick. 0.2 multiplied by the unit weight, we get 5 kilonewton per meter square. Floor finish, we get 2.126. 100 mm thickness we need to consider, and then plastering thickness also we need to consider. So we get 2.126, and for terrace slab we need to consider the waterproofing load. So that comes around 1.6, and sunk load it is 2 kilonewton per meter squared. If you consider 250 mm sunk thickness, and then if you consider the unit weight of the cinder filling as 8 kilonewton per meter cube, so we get 2. And staircase load, let's consider 3 kilonewton per meter square. And here I have the wall load. So we know the beam depth we have 600 mm and then 750 mm. So I have calculated separately. Height of the wall we have 3.5 meter. So 3.5 meter minus beam depth of 0.6, we get 11.6, and if the beam depth is 0.75, we get the value as 11. Parapet wall load is 2.4 kilonewton per meter. So these load we need to apply it in Staad Pro. So first go to dead load. Let's add the wall load first. Go to member load minus 11 kilonewton per meter. This is for the beam depth of 750 mm, and then 11.4 kilonewton per meter. This is for the beam depth of 600 mm, and parapet wall load is 2.4, sorry it is 11.6, and then parapet load is 2.4. This we can add 11.6. Parapet is 2.4. We add this 11.4, we don't want this, we can delete. So we have added all the wall loads. Next we need to add with the self weight. So for that what we can do is we need to create a group. Before creating the group, let's apply the wall loads on the length. We know the beams which are parallel to Z direction, so that is 750 depth. So go to select beams parallel to Z direction. So in this one we can assign the beam depth as 11 kilonewton per meter. Assign to select the option assignment method as assigned to selected beam, give assign. So it is assigned. Next, beams parallel to X. So we can select this one too. In this we can assign the beam load as 11.6, give assign. So now the beam load is assigned, wall load is assigned to all the beams. Next, let's go to view, display whole structure, and again go to this view. Now let's select this one, go to this selected objects only. So here you can go to select beams parallel to Z, select this one and go to this 11, assign to selected beams, assign. And again go to beams parallel to X, select this 11.6, assign. See, now all the wall loads has been assigned to the beams. Now let's select this one, go to translational repeat. We can select in the Y direction. The height is 3.5. Let's check 1, 2, 3, 4, 5 steps we need to add. Number of steps we can give 5. Give OK. So G 1, 2, 3, 4, 5. G plus 5 we have got. Now all the loads has been assigned. We need to go to this terrace area, selected objects, isometric view. So in this what you have to do is, see, the wall loads has been assigned. Go to select beams parallel to X as well as beams parallel to X. You select first beams parallel to X. Give toggle load, assign to selected beams, assign. So it has been removed. If you give this option toggle load, it will be removed. And again go to beams parallel to Z and then select this one, assign to selected beams, assign. This is the one. Give toggle load, now give assign. This is this one. Don't forget to uncheck this, otherwise all whatever the load you will be adding, that will get deleted. Now see, in this terrace floor there is no load. Now what we have to do, we have to select all the outer beams only, and then we need to apply the parapet wall load. Assign to selected beams, assign, close. So after this, what we have to do is, we need to do some modifications in the geometry. So this staircase area and the lift area, you have to take it to the upper floor. So only this we are going to take. Go to translational repeat, geometry, translational repeat in the Y direction. Let's consider 3 meter height. Give OK. So this we have taken like this. Now this one we can merge. Go to, we have done the merging. Next what we can do, just select all these things. This is at the staircase headroom level. Next let's add for the left machine room and then OHD. So go to geometry, translational repeat in the Y direction, just 2 meter height let's add for the lift machine room bottom, and again let's select this. Should have given 2 steps over there, so that it will be okay. Let's add the columns and then let's copy this one. This one we can do now, translational repeat the Y direction, 2 meter, give OK. See, now we have added all the things. The structure is completed. Next let's go with the grouping. Let's select this floor, go to view, selected objects only. Self weight of the slab and the floor finish load we need to add. So for that, let's create group for each floor and then we can add the floor loads easily. Give Control G, group name, ground floor, roof. You are not supposed to give spacing, and here give floor. OK. So ground floor roof is created, but it is unassigned. So to create ground floor roof, we have to select the floors. So in this we have openings here, here, and this is also opening, and here we have the slab, and this is staircase area. We'll create separate this one for staircase area, and then we'll assign the load. This we don't need to select. This is opening area, and see here, this we can select, and these all 3 are opening, and this we need to select separately for staircase. Best all we can create like this. So if you select this one, ground floor roof, highlight means it will show you this area. So this is the, oh sorry, this needs to be, this also needs to be selected. So this area needs to be, now select this one and then highlight. See, all the slabs has been selected without openings. Now again create first floor roof, floor, give OK, create second floor roof, third floor roof, fourth floor roof, fifth floor roof, terrace we can add, and then we can add headroom. I have created all the groups. So if you look into this ground floor roof and highlight, so this geometry is assigned to ground floor roof, and if you select first floor roof, it is highlighted, second floor roof, third floor roof, fourth floor roof, and this is for terrace. And when you select stair, see it will select all the stair area, and then headroom is assigned separately, and LMR bottom, this is for the lift machine room load, and this is for OHT bottom, that is tank load, and this is for LMR and OHT top. So I have added separately to avoid the confusion while applying the loads. Now let's close this one and go to loading. We have completed the wall loads 11 and 11.6, 2.4 is the parapet wall load. Now let's select the missing properties. If any property has been missed out, go to select missing property, select missing property. See, these many columns have not assigned with the property. Go to properties, select this one. This is the column dimension, right? Go to select again missing property, only selected objects. So these all columns. Now we can give assign, and even materials also we can assign concrete. Close. We go to view display whole structure. Now go to select missing property. See, now there is no entity with missing property is found. Let's start assigning the floor load. Click on this dead load, click add, and then here select floor load. In the floor load we can select group over here. So it will be giving you all the group which we have created. Now what we can do, we can go to this one. So in floor load we have to add this 5 kilonewton per meter square, and then floor finish we can add 2.126 for all the typical floors, and then for terrace slab along with the self weight we need to add the waterproofing load. Here in Staad Pro self weight command is there under load, so that we can add. So the beam and column self weight will be automatically calculated by the Staad Pro software. For slab we have not assigned the plate element and we have not added the plate thickness. So self weight of the slab we have to add manually as a pressure on the floors. So that's what we are doing here. So ground floor I am selecting. So it comes around negative 7.126 kilonewton per meter square. You can just add, and if you close and see, let me select only that ground floor and then show you. If you look into this, you can clearly see the loading detail, how the load has been divided. These are all the open area. So in this area there will not be any loads. Next let's go to whole structure and go to add, and then floor load group. Let's select first floor roof. Here also you can add negative 7.126, give add. Again second floor roof, add. Third floor roof, add. Fourth floor roof also we can add. And then coming to terrace, terrace is 5 plus 1.626, it's 6.626. So we can change this one 6.626, give add. Now see, this is ground floor, first floor, second floor, third floor, fourth floor, and then terrace. So all the load we have assigned now. Next let's go to dead load, add floor load group. So let's add the stair load. If you go to this calculation, stair load we have taken as 3 kilonewton per meter square. So let's add -3, give add. See, if you select this one, for all the floors it has been added. If you go to this view, see the star load has been added to all the floors. Next go to dead load and then let's add floor load group. See here we have the headroom and the headroom will be having only the self weight of the slab. Let's add 5 kilonewton per meter square only. Give add and the headroom it is added. Next let's go to this floor load group LMR bottom. So on the LMR bottom we can add 10 kilonewton per meter square, which includes lift machine load and the slab load, slab weight. Give add and then let's apply this one as overhead tank load 14 kilonewton per meter square. And LMR and OHT top, we need to add the self weight of the slab only. Let's add 5 kilonewton per meter square only. Give add. And then if you go to sunken area, if you see in the architectural drawing, in this area we have the toilet. So this will be sunken. So sunk load, we have 2 kilonewton per meter square. So that we can add in this. Give add. Close. Now if you see this star load, it is added and then headroom floor load it is added. Next, sorry, by mistake it is the 10 kilonewton per meter squared has been added to the ground floor roof. So this we need to add to the LMR bottom. So this we can delete. We can again go to dead load and then go to add floor load group. Select LMR bottom and then minus 10 kilonewton per meter square. So now if you see this headroom, this is OHT bottom, this is OHT and LMR top and sunk load, and this one is LMR bottom. All the loads has been added now. Dead loads are done. Next let's go to the live load, add floor load group. Since it is a commercial building, let's take 4 as the live load for all the floors, and only for terrace we need to consider less. First floor roof we can add, second floor, third, second floor is added, third floor add, fourth floor we can add, and terrace we can apply 2 kilonewton per meter square, add. And when you go to this headroom and all, if it is not accessible, we can add 0.75 as the live load. LMR top, third floor, fourth floor, terrace we have added, headroom, and then this one. We have added all the loads. Next let's add the, go to dead load, give add, self weight, you can add. Now you have to select all the members and then assign to selected beams. So self weight has been assigned now. So if you look into this, we have added EQ load, dead load and live load. Next what we have to do is we need to define the response spectrum cases. Before that we need to add the mass source. That needs to be done for the static analysis as well as the dynamic analysis. So under reference load definition we can add the mass source. Click on this, give add, and then go to mass. Here we can give the title as mass, give add. So this we can add it manually, or else in Staad Connect edition we have the option under loading. You can select this mass model generator. We can add, otherwise we have to go to the Staad editor mode. So in this we have all the loads, member load and floor loads we have. If you see here, we have the member load, this and the floor load, or whatever we have applied, all we can copy and we need to paste it in the word sheet, and then we need to change the negative sign. Then we can copy and paste it under the seismic definitions as a seismic weight. Why we are taking this mass source and seismic weight is we are going to find out the seismic weight of the building. As per IS 1893-2016, seismic weight of each floor is its full dead load plus appropriate amount of imposed load. So this we need to consider. Percentage of imposed load is given in table 10. If we consider live load up to 3, we need to consider the live load as 25% of that. If the live load is above 3, we need to consider 50%. Let's go to start and mass model generator. See, here we have the dead load and live load. Only these two load cases needs to be selected because only these two are used to find out the seismic weight of the building. See, here live load is considered as 0.5 because the live load we have entered as 4 kilonewton per meter squared on all the floors. So it is above 3. So above 3 we have to consider 50% of the live load. Now we can give generate. See, if you select generate, here you will be getting all the loads. Under mass we have all reference mass model. This we can delete. I think this is the one we, so here all the dead load has been added. If you look into this, this is in the upward direction, so negative sign you are not supposed to use. And all the sunk load, lift load, everything is taken, and self weight also. And if you look into this, see, this is the live load. So we have assigned the live load as 4 kilonewton per meter squared, but the Staad has taken as 2 kilonewton per meter square. And there is some mistake in this headroom, floor, and lift machine room and terrace and all. The live load has been considered as per the code IS 1893. While calculating the seismic weight, the roof live load need not be considered. So that we can change by using this editor mode. Go here, go to this define reference load, click on this. All the loads has been added over here. So in this till here we can keep, and after that terrace load and this load and all we can delete. There is no need of these loads. And then in define reference load we can save and then close. So if you look into this reference load combinations we have added, if you look into this reference load definitions we have added, and then seismic weight definitions we have added, and under load case details we have added seismic load cases, and under this load case details we need to add the load seismic load factor as 1. And if we go to this one, this is in the negative direction, factor as -1. Oh sorry, seismic load factor as -1. Add this one we can delete. And z direction, go to seismic load factor as 1, negative z direction. All the seismic load cases we have added. Next we need to add the response spectrum cases. In this I'm going to select seismic. Let's add r as positive x, add, and then r as negative x, add, r as positive z, add, r as negative z, add. We have defined the response spectrum cases. Next we need to add the values. Go to response spectra. In this code we have to select IS 1893 part 1 2016 combination method. Let's select CQC. Subsoil is medium soil. So here we can add the values. The value is 0.024 response spectrum values. Give add and then close. Next select the negative direction and go to response spectrum CQC medium soil, and in the x direction negative direction give add. We have completed the load case details. Next we need to add the load combinations. To add the load combinations we can choose this option automatic combination. Select this one, automatic load combination. Under this we have to select the code IS 456 table 18 and select starting combination number is 11. So we have completed the load case details with 10. So it will start the combination number with 11. Give generate load. See, the load combination has been added over here. Just give add and then close. So if you look into here under load case details, the load combination has been added. And also you can go to the Staad editor mode, and here load combination you can select. These are all the load combinations we have. 1.2 times dead load plus live load. When you consider seismic load, we have three main load combinations: 1.52 times dead load plus live load plus seismic load. And when you have another case, that is 1.5 times dead load plus seismic load, and 0.9 dead load plus 1.5 times seismic load. So all the combinations have been added. Let's save this one and then close. Next we can go to this analysis command, and then we can select all. Perform analysis, we can select all, and then we can add. Before that, let's check the geometry once. Go to this utilities. Under structure tool, select multiple structure. We have only one structure. And under node tools, we can select the duplicate nodes. No duplicate nodes found. Under orphan nodes also we can check, and then beam tools, duplicate beams. Zero length, we can check the tolerance. No zero length number. And again overlapping beams we can found. That's it. The checks all done. Next, let's add the analysis and design data. Go to analysis command, select this perform analysis command. It is already added. Give add. And next one is go to concrete design, and here you have to select IS456. Select parameters. First, select all the parameters over here. We can add clear cover, compressive strength of concrete we can add, yield strength for main reinforcement, secondary reinforcement, maximum size of main reinforcement, secondary reinforcement, percentage of reinforcement we can add, and then give OK. Next, go to define parameter. We click on this clear cover. Let's add the clear cover for beams, that is 0.025 25 mm. Give add, and then let's add the clear cover for columns 0.040. Give add. And compressive strength of concrete, let's add 30,000 since we use M30. Main reinforcement, let's add 500. Give add. And then secondary reinforcement is 415. Give add. And maximum size of main reinforcement is 25 mm. Secondary reinforcement is 10 mm. And percentage ratio, let's take maximum percentage for column as 4, and then for beam it is 2.5. I'm restricting to 2.5. Give add, and then close. And go to command, design beam, add, design column, add, and then concrete takeoff, add, and then close. So this all we need to assign now. Clear cover, let's select to beam parallel to X and beam parallel to Z. So this is for beam, right? So give assign. This is assigned. Next, clear cover for column. Go to select beams parallel to Y. Give assign. Next, this is for the whole structure. Give assign. And again, this is for assign to view. Give assign. This is also assigned to view. Give assign. This is also assigned to view. This ratio is for column. Give select beams parallel to Y and then give assign. Next, this is for beams. Select beams parallel to X and beams parallel to Z. Give assign. Next, design beam. Again, beam parallel to X and Z. Give assign. Design column. Beams parallel to Y. Assign. That's all. We have applied all the design parameters. Now let's go to analysis and design. Let's run the analysis and see. We have 106 warnings. Let's go to the output file and then see how we can resolve all the warnings. So here we have the warnings file. If you look into this, mass model will be used in seismic response and time history method if any. So this is just information. Let's look into this one. UBC or IBC analysis has tension and compression. The message is given here. See here we have to do the reanalysis or select optimize, then each UBC IBC case should be followed by perform analysis and change. So there is one condition in the seismic analysis. So after each seismic load cases we need to add this command perform analysis and change. That we will add. And one more thing is this one. This is the common error we get, warning we get. The base shear from the response spectrum is less than the base shear BB calculated using empirical formula for fundamental time period. Multiplying factor according to the class, it is 2.26. So this multiplication factor is given, so that is given as one warning. And then here if you see, this is one warning: length to depth ratio for member is less than 2.5. So if you look into this, deep beam is not designed, assume it to be part of continuous beam. So for this we have to provide the inch and wrench parameters. So this we have to provide in the design design parameters. So first we will add that perform analysis and change command, and then this inch and rinse command also we can add. So this is the common error. Most of the errors are this warnings are this one. And again, next one is percentage reinforcement percentage exceeds maximum limit, unable to accommodate the required reinforcement. So in this case we need to increase the size, like column size we can increase. So let's do the changes over there. Close this one, go to this command editor. See, when you click on this load one, that is EQ positive x direction, EQ negative x direction, EQ positive z, and EQ negative z. So what you have to do after this, you have to enter the command perform analysis change. This you can copy and then paste it over here for all the load cases. Only seismic load cases. Perform analysis and change. So this is the one command we have to add. And next what we have to do is that inch parameter we need to add. Let's look into the concrete design. So after this, here we can add that inch ENSH1. One is the value, and then MEMB, that is for member. See, we have the member numbers here. So these many members are having length to depth ratio less than 2.5. So these numbers we need to add over here: 599, 605, 607. I hope you can see here: 597, 599, 605, 607, 608. This way we have to keep adding the numbers. 608. So I have added all the member numbers. Now let's save this and then close. Let's go to the property. This we will edit column size. Just we will give the column size as 0.4 instead of 0.3, and then see what happens. Now let's do the analysis again and see what are all the warnings we are getting. So we have now only 6 warnings. Let's see. So we have 6 warnings. If you look into the warning, this is the one. So that perform analysis and change, that command statement needs to be given like this. Okay. And next let's see other 5 warnings. We need to add this member. I think these 5 members are missed out. So let's add that one. Go to command file. And in the command file, go to the load type 1. So here I think it is not properly saved. So let's add perform analysis and change. This is x, this is negative x, this is z direction, but here it is mentioned as x. So that is why it is showing some of the warnings, and this also we need to change. Always you have to be familiar with this command editor file, so that will be very useful in Staad software. So in this one we need to add few member numbers. Go to this analysis output: 926, 927, 928. See, here it is there up to 923. So we need to add 926, 927, 928. 26, 27, 28 we have added, and these two we can cut and paste it over here. And one more is 1033. This is 1033, 1033, and here we can add 1242. You can save and then close. Again it is showing some warning. At perform analysis change syntax is wrong. Perform analysis. See the change. So the syntax need to be like this. So that is why it is showing error again and again. Save and then close. Now we can do the analysis again. See, now we have zero error and zero warnings. Let's go to the output file and see, and then let's check the modal participation factors. We go to here, click on this one. We'll be getting the mode participation factors over here. See, Staad automatically calculates 6 modes, first 6 number of modes, but we have got the percentage as 81 only. This at least we need to get 90% as per the IS 1893 2016. So to get this one we need to change the mode numbers. Let's go to, let's close this, and here to get the mode numbers you have to go to this miscellaneous command and cut off mode shape. So maximum number of mode shape, it is 6 is there. Let's give 15, give OK, yes, and then we do the reanalysis. Go to output file. Now let's go to participation factors. See, now number of mode is 15, and if you see the percentage participation factors in percentage, it is 90. So we are getting 90 at the 13th mode. So that is fine. We are getting satisfying the code. Next, let's look into the details, design details, beam and column. If you take this beam, the size is given here, length is given here, and the reinforcements are given here. Top reinforcement area, summary of reinforcement area, and here we have the reinforcement details. These details we need to change because it is given as 14 number of 10 diabar, 2 layers, 7 number of 10 diabar, but these we need to change, and here it is given shear reinforcement. So in this way the beam reinforcements are provided by the Staad. We can take the area and we can arrange the reinforcement as per the detailing requirement. Next, let's look into the column. If you take this column, steel area, concrete area is given here. So if you look into this detail, the interaction ratio it is 0.06, and if you take the worst case also, the interaction ratio is 0.75. It should be less than 1. So it is satisfying the codal requirement. So in this way reinforcement details are given. Let's close this one. If you want to go to post processing mode, you can just click on this, and then we can select the load combinations from 11, select apply, OK. So this is the post processing mode. If you wanted to see the deflection, you can just click on this, and then this is displacement. And if you want to check the shear force diagram, so this is the shear force diagram. You can just close, and bending moment diagram is this one. If you want to get the values also, you can get it. So here we have the reports, support reactions, beam and forces, displacement, everything we have. So friends, that's all about analyzing and designing the G+5 commercial building in Staad Pro Connect edition. I hope you all like this video. Please do comment in the comment box if you have any queries. And also don't forget to subscribe this channel for more videos. Thank you for watching.